Okay, today is the last question for the day, at least for me. Okay, after this I'm going back home. Okay, now for this question we are looking at the simple concept known as power. Okay, just to recap, power, okay, the formula for power, okay, is energy divided by time, or what we call the rate of energy conversion. Okay, before we use this formula, students, like I mentioned in the video before, there are a few key things that students need to remember. Okay, for example, to use this formula, the time that given, or the time that you substitute inside, has to be in SI unit seconds. Okay, and the energy usually is always in joules, SI unit. Okay, make sure if you have prefixes like kilojoules or maybe a megajoules, you need to make sure that you convert it, or you expand the prefixes. Okay, so after that, when only your joules is in SI unit, energy is in SI unit, time is in second, then your answer derived from this formula will be actually correct, because it will be in the correct unit known as watts. Okay, this will be the first way that students need to be careful. Second thing that students need to be careful, like I mentioned in my video also, okay, is the concept of useful power and energy loss. Okay, because quite commonly we have like a portion of the energy. This is the energy that is given. Okay, it can be usually it's like the energy output. Okay, the final form of energy. Yeah, and sometimes among this output energy, at least a portion of it is actually what we classify this as useful energy. Okay, so this would be what we call this would be what we classify as useful energy. Okay, so in this perspective here, this would be useful energy. Okay, and the remaining of the portion here that we are looking out for, this portion here will be what we call energy loss. Okay, and like I mentioned before, when we talk about energy loss, it's always best to actually include the location or the forms. For example, energy loss to environment, it could be due to air resistance, or it could be due to friction between the surfaces. So I actually need to know the type of energy, which is energy loss to environment, thermal energy, plus I will need the location of the energy loss. So if it could be friction between the surfaces, or it could be air resistance, okay, when it's moving down the particular track, or even like air resistance when it's moving, when the car is moving. Okay, so what happens is, under a type of energy, I can actually classify into what we call useful and loss. So depending on the question that's given to you, the numbers that's given to you, the numbers or the quantity could actually be useful, and from there you need to work out useful energy, and you need to reverse engineer it to be the final amount. For example, I can say the useful energy is 80%, so calculate the 100%, or the original amount of energy, or maybe calculate the energy loss, okay, which is 20%, to calculate the exact number. Okay, so with this in mind, okay, let's look at question 6. Okay, a simple one. Okay, in this case the question is quite simple. You have a depth of the well which is 5 meters. Okay, and it raises a 200 kg of water every day. Okay, what's the useful power extracted from the wind? Okay, in this case the question doesn't give much information about what is useful, so it's safe to say that whatever energy that is generated here is totally converted to be as useful energy. Okay, but take note, this question here I can actually say that the useful energy is actually 80%. Okay, so calculate the portion of energy that is considered as that is useful. Okay, so it depends on how the question is being structured. Okay, but for this, it will be a straightforward case whereby I just look at the formula. Okay, and in this case, the energy that we are talking about here is actually potential energy, because the object is being raised through a height of 5 meters. Okay, so and the time taken here we are looking out for is actually a day. Okay, every day a day. Okay, so this will be 24 hours. So the timing that we are looking out for is every day. So every day, it actually means this is 24 hours. Okay, so now let's look at how do we substitute the equation inside. Okay, so for energy here we are looking out for will be potential energy, so it was simple mgh. Okay, so double check, make sure everything in SI unit, so mass is in kg, okay, followed by height is in meter, so these two are accounted for. G, gravitational field strength, is 10 Newton per kg SI unit. Okay, so we have settled more or less these two. Okay, so this is SI unit. I will be able to substitute straight inside. Height is in meter, so I just do a direct substitution. G will be direct. Okay, then what about T? Okay, T, take note, T here is 24 hours. Okay, so T here you need to convert this to be in seconds. So 24 hours, the ratio that I given to you, okay, 1 hour is 3600 seconds. Okay, this ratio I given to you in the video. If I remember correctly, it should be 6.3. Okay, just go back and take a look, okay, at that particular recording pertaining to power. So 1 hour is 3600 seconds, so 24 hours will be minutes, second, so it will be converted to seconds here. So in this case, my mass, okay, which is 200 kg in SI unit, okay, my G, my height, okay, which is SI unit 5 meter, okay, so it will be 5 meter. Gravitational field strength here, in this case, it will be 10 Newton per kg. Okay, so my substitution will look like this. Okay, so if this is a normal structure question that you see in your paper 2, the next step you do is actually look at it, put the number inside your calculator, and the answer given here, take note it has to be in joules, and it has to be 2 or 3 SF. Okay, but since we are looking at the MCQ question, so right now instead of looking at the calculator, all you need to do is look at the choice that is given to you and identify the one that matches your answer, and you happen to be B, sorry, so sorry about that. Okay, so I hope this video will clarify some of the things, and I repeat again, some of the things that you need to be careful when you use power. Okay, make sure the components are in SI units, your energy is in joules, power time is in seconds, and when these two are the correct unit, then your power will be calculated in terms of watts. Second, okay, things to take note is that the type of energy that is given to you, the proportion of energy, whether it's useful energy, whether it's heat loss. Okay, so you need to know what are your components. Okay, and you look at it as, after that you reverse engineer using simple rate ratio. Okay, with this I will wrap up 7.4, which is power, and the next stop that I'm looking at, the next point that I need you to do is your worksheets. Okay, further practice on this topic so that you can sharpen your concept and to identify where are mistakes. Okay, I will go through some of the worksheets in the tutorials in the worksheet, okay, to run through some of the common mistakes that I actually encountered in my years of teachings. Okay, with that, okay, this is the end of my video, and I'm going back home.